How's it going, guys? Just want to break you through how to find the y-intercept. In this t-table right here, we need to figure out where our y-intercept is. That's our b value, because that's our y-intercept. And this is our b value right here, when x is equal to 0. When x is equal to 0, y will be equal to 4. I'll show you how that looks on the graph in a second. Let me swing back and adjust this thing for a sec here. Let's see if we have another problem down there all written out for you. And doesn't look like this thing's going to want to stand up straight. So, I'll put something under it here and try to shift it a bit forward on you. In this problem right here, we have two sets of zeros. Don't want you to be confused. That is not our x equal to 0. That's y equal to 0. So this guy right here is going to be our y-intercept. Right? Very important, because x is equal to 0. So I know what you're thinking. I'm going to move the camera here. Sorry for you viewers at home. It's going to get a little jittery. But we're going to zoom back out. And here we go. Both of these equations are graphed right here. See if I can't set this thing down and kind of make it work for you here. If both of these equations are graphed right here, okay, all of these points, here's -2, -2, there's -2, -2, so that's this point right here. And here's -1, 1 right there. So this line right here is represented by this function. Now if I have just this point, I'm there, but I can see from this line that this is where it intercepts the y-axis right here. And that point is 4. And that is our b equals 4. We just take the value directly for our y-intercept. Let's do it again for this other line right here. See, we have -2, -2. So we go +2 right there. And -1, 0. Okay, we go back. -1, 0. So this line right here, this dot, is on the x-axis. That would be an x-intercept. And then as we go down again, 0, -2. Well, I'm looking for the point where it crosses. So there it is right there. And that point represents the y-intercept. So right here, y is equal to 2. And that's for this line, which is represented by this t-table right here. And that says b for this equation equals 2. So we need to figure out, how do we draw an equation of a line given these things? Well, we take our differences right here, right? And this is going down by 2 each time, down by 2. And then over here, this is going +1, +1. So we need, to do our equation of a line, we need y equals mx plus b. Gotta have that b, gotta have that m. And here's our slope. To find our slope, m is equal to the rise over the run, because m is our slope. And that represents what's changing in the y's over the x's, right? So we also write it sometimes y2 minus y1, x2 minus x1. But all we really need to do is look at the change right here on the y side, which is -2. So our rise is -2. See if that's on the camera for you. Cool. And our run, which is over here, is +1. So in this great example, what we have going is a rise of -2 and a run of 1. So in this example, our m is equal to -2 over 1. Or we just write that without the 1 on the bottom as -2. Time to put it in the line. So we have to go ahead and take our y-intercept for this line, which is 2, right, or negative 2 right here. Sorry about that, viewers at home. There's negative 2, definitely a negative 2 right there. And that's wrong too. Hey, what can I say? I'm perfectly mistaken. My wife will tell you that one. So here goes. We got y is equal to mx plus b. And what do we really want to put in now? Well, we have our slope is negative 2. We're going to remember that number, so I'm going to take it out here. We're going to write y is equal to negative 2. That's our slope, negative 2 over 1. There's our x. And then instead of this, we can write plus negative 2. Now the final form of this equation would be y is equal to negative 2x minus 2. Let's see if we can go back to the other one here. And we want to do this top form. So I'm going to try to tip the camera a little bit for you guys and work above right here. Okay, so we're going to take this guy right here, and we want an equation for this line as well. That's this line right here. Remember that our b is 4. So if I wrote the equation right now, y equals mx plus 4. I know that that's my b. That's where the plus b is. See, the b here is 4. So we've got that. But we do need to find a slope. Well, I remember how to do the slope. We take our differences right here, and we're going right here, plus 3, right? And this is also a plus 3. And as long as all these are the same, you can see that's another plus 3. This one right here is going to be a plus 1. And from here to here is a plus 1. So it's a fair bet to say that's 3's all the time, and that's 1's all the time. So our rise right here is 3, and our run is 1. Now we can count this on our graph too. If we go from one point and we say, how far have we gone up? Well, here we go. 1, 2, 3 on the rise, 1 on the run. 1, 2, 3 on the rise, 1 on the run. So there's our 3, and there's our 1. And this would be another 3 and another 1. So that also is a slope right here of 3. That's our m. So let's put the final piece in and write this out for everybody at home. I got a little carried away with my mx plus 4 there, so we're going to tip that up for you. I'm going to glare on that screen, see if we can't do that. Any better? I don't know, we'll see. So let's write the final equation here. We got our b is 4, and we're going to put our m in, so we got y is equal to 3x plus 4. This is the equation of this line right here, and this guy right here is the equation of our lower line, although you can't see that, but there it is. Our lower line is in the box, and that arrow right there is pointing over to it. So I hope that's a helpful recommendation for you guys on how to find your y-intercepts and also how to write the equation of a line. Keep in mind that this is what's called slope-intercept form. Good luck.